The presentation will be about anode-less solid-state lithium chemistry enables fast charging microbatteries with high energy density. Thank you very much, and the stage is yours.
Appreciate it. I appreciate everyone's time. So I'm going to be speaking about our technology, which we've been working on for the last 2.5 years at Ensurge. And as you see in the picture there, that's an inset of the stacked solid state microbattery. And to give a rough order of size, that would be about 8 mm by 8 mm in footprint, with a height of a few mm. Um, So, a quick word about the company. We are based in San Jose, California. We have been working on a thin film solid state microbattery over the last 2.5 years, taking that from initial development into commercialization. We have our own roll-to-roll facility here. We have made it quite clear that the way to achieve a cost, scale, and a path to commercialization is really to have a roll-to-roll product approach for these kinds of batteries. These are targeted at a quite a significant opportunity in the emerging class, emerged class rather, uh, of hearables, of wearables, of IoT devices. What we are not is an EV technology. So we are not interested and cannot use this technology for very large batteries. This is very much aimed at the microbattery space. By that we mean about 1 to 100 milliampere hour, and that's the sweet spot uh, of where this works. As I said, we are based in San Jose, California, and we have a full R&D as well as scale up line over here. So let's go first into the what the architecture of the battery is. This class of battery and technology, in terms of a thin film lithium-based cell, has been around for a while. The gap between capability and scale has really been about making the right choices to get to the right form factors. So as you saw earlier, we are uh, targeting applications where space is a primary constraint. Um, so by definition, we have to achieve adequate battery capacity, but in a very form factor restricted volume. So volumetric energy density is one very big key. The other part is flexibility in terms of the form factor. All spaces are not created equal, so we have to have a form factor freedom where we can change the height, the width, and the length depending on the application uh, of the customer. So to get to high volumetric energy densities, since this is a thin film cell, the energy containing layers tend to be quite thin uh, uh, on the cathode, etc. So it's very important to get to high VEDs that we minimize the thickness of the substrate. A lot of the batteries in this class work on silicon substrates and other things, which can be, which can be hundreds of microns thick, which is a significantly higher number than the actual thickness of the cathode. So one thing we did upfront is we wanted to use our expertise in stainless steel based devices on roll to roll to use an ultra thin 10 micron thick stainless